I hope you guys are doing really well. So let's see today's daily challenge on Leetcode and we will try to solve it together. So today's challenge is a little interesting one. So let's see. Paths in matrix whose sum is divisible by k. So you are given a zero indexed m cross n integer matrix grid and an integer k. You are currently at position 0, 0 and you want to reach the position m minus 1, n minus 1 moving only down and right. Okay. So return the number of paths where the sum of elements on the path is divisible by k. Answer may be very large, so you may want to return it modulo 189 plus 7. Okay, so yeah, so you need to count the number of paths from the cell 0, 0. Okay, so this first cell 0, 0 to the last cell, to the bottom right cell, and you need to count the number of paths in which the sum of the numbers in this path is divisible by k. You will also be given this integer k. So if you think how to solve this exactly, so what is required at first? So what will be your first thoughts on this question? Okay, so you can be given any rectangular matrix starting from 0, 0 to something like m minus 1, n minus 1. Okay, so maybe you are following this path, you get some a particular sum s. Let's say you are following some other path by which you will be getting this s1, and you need to count the number of paths s1, s2, whatever be the sums, the sums which are divisible by k. Okay, so if you do, it's like s of I modulo k should be equal to 0. Okay, this is the thing which you need to check, and you are allowed to move only right and only the down. So let's try to solve this problem. There is another question on Leetcode also, that how many paths are there. Just you need to return the number of paths. There are no conditions like it should be divisible by k or whatever. Okay, so what if the question is something like return the total number of paths? See, I have already discussed this problem in my DP playlist, and yeah, still I would like to go through this once again because it is very relevant here. It is a very similar thing. So if I ask you that currently you are standing at 0, 0 and you can take right and down only as your turns, and you want to reach this last cell, how many total number of ways are there? Okay, so you can easily see that if I try to ask on the first row how many number of ways are there, so you will say that let's say take this point. Okay, and you are asking me that how many number of ways are there to reach this point. There is only one way, because you can only go straight. If you ever go down, you cannot go up to reach this point again. Okay, so there is only one way. So in this whole DP table you can write that 1, 1, 1, because there is only one way for the first row, and similarly for the first column, all the values you can see you can only go down, so there is only one way by which you can reach. So 1, 1, 1 again, and so on. Okay, so that's what. And at any point, if you see, if you try to see this, you can see that one way you can reach this point, so another way you can reach this point, so you can reach this point in this plus this number of ways, that is 2 ways. So what I am trying to say is that when you are at cell I comma j, you see from where could you have come from this cell to this cell. From where could you have come? See, you could have come from I minus 1 comma j. You could have also come from this ij minus 1, because you are only allowed to take down and right turns, right? So this is the way which you could have reached this point I comma j. And you see, if there are a ways to reach this, so let's say 0 comma 0 is somewhere here, and there are a ways to reach here. Okay, and maybe b ways to reach this point, so there will be definitely a plus b number of ways to reach this point. Okay, so that is the DP transition. In that case will be simply DP ij equal to DP I minus 1j and plus DP ij minus 1. So I hope you already know this sub problem. Okay, now this is a very similar problem. Okay, so you are only having the additional criteria that the sum should be the path sum should be divisible by k. Okay, so we try to analyze once again how we can approach. So you see, what you will do exactly is that try to think of some middle path, middle cell. Okay, and you want to reach this cell at last, and you are currently on this cell. Okay, so let's say you have reached, taking some path, you have reached this particular cell, and you see that the path sum modulo k. So far what is the remainder so far? So see, only the remainders are mattering, right? So you are given a k value, so you take modulo k and just try to store the remainders. So you see, let's say you have a remainder of x. So this whole path, if you just add the sum and if you do modulo k, let's say you get x. That is what I am trying to say. So let's say coming through this path you get a remainder of x, and let's say coming through some other path you get a remainder of y. Now by the time you reach this, you need to count how many paths have a remainder of 0, isn't it? Is completely divisible by k, that is have a remainder of 0. So it is definitely possible that right now the remainder is x, but maybe if it follows some path it will reach and have a remainder of 0. So you need to keep a track of all the remainders also, right? And maybe it is also possible that right now it is having a remainder of y, but maybe if it takes some path like this, and maybe it is also able to take become 0 at some point. So we should not forget, even if the remainder is non-zero in some middle cell, we should not forget its value, right? It may become 0, the remainder may become 0 by adding these path elements afterwards, right? So what we can do, here comes another dimension of the array, is this k. So if you do modulo k, what are the possible remainders you can get? You can get a remainder of 0, you can get a remainder of 1, you can get a remainder of 2, and so on till k minus 1. You cannot get a remainder of k, because that would mean that you are getting a remainder of 0 only. So basically what it is trying to say is that see, it gave a remainder of x, it gave a remainder of y, and there are some ways to reach this. So I do not want to forget this ways. So so basically what the thing is that I do not want to forget the ways, no matter what the remainder is. Although I want a remainder of 0, although what I want is remainder equals to 0. Although you might be thinking that in the final cell I want a remainder of 0, but I still want to keep a track of what is the number of paths in all of the remainders, right? In all of the remainders. So there comes another dimension in our DP, which is till now only x and y, it comes only k. Okay, so there is one extra dimension which I added. This is the reason. Okay, so you can define a DP xyz, okay, or let's call it ijk. It sounds more correct, right? But yeah, you can do it anything. So what does this denote? It will denote that from 0 comma 0 to reaching I comma j, what is the number of paths that leaves a remainder small k. Okay, so basically don't confuse with the actual k and this iterator k. This is the iterator k, not the actual k. So you can call it, let's say, k dash. Okay, you can call it k dash. So basically dpij k dash denotes that the k dash can range from 0, it can range from 0 to k minus 1. That is all the remainders it can go to. So basically it tells you that dpij k dash tells you that from 0 comma 0 to I comma j, how many such paths are there which leaves a remainder of k dash. Okay, that is what is told by dpijk, and you can use the exact same formula. You see, dpi minus 1 j, you can calculate for I minus 1, you can calculate for j minus 1. Just you need to take care of the remainder, just you need to add this remainder. So how do you change the remainder? So you see, there is a value at grid ij, so you just add grid ij to the value and take whole mod, that will whole mod of k, that will only give you the remainder, right? That is nothing but the remainder. So yeah, you can have a simple triple for loop and just populate the array, and at the end what you need, see, at the end what you need dp of let's say you have this as n, okay, and this as m. So n rows and m columns, so you need n minus 1, m minus 1, 0. What does this mean? That what is the how many number of paths are there from to reach from 0 comma 0 to n minus 1 comma m minus 1, leaving a remainder of k dash, that is leaving a remainder of 0. Okay, so that is what you actually need, right? So that's how you get to know. And yeah, I will try to write a directly iterative version of the DP. I will also tell you, if you are struggling with DP and all, you can follow my DP playlist. Till now I have also explained you how you can directly go to the iterative version, how you can think it in this way and reach the iterative version without the need of any recursion, memoization and all. But yeah, it is beneficial to follow those steps at first. So yeah, I hope you did follow, but for this problem it is just a waste of time to follow recursive approaches and all, because only the iterative version directly is very simple and easy to understand, also not difficult. I hope till now whatever I told you did understand, right? Yeah, if there is still any doubt, you can definitely ask me in comments. So with all this knowledge we can directly start to code. Okay, and you see we will do it quite fine. So we have the number of rows, which is n, as we told. Let's say grid dot size, and m will be grid of 0 dot size. Okay, so you have these two, and you do have a 3D DP, right? So you can allocate the memory dynamically, vector of vector of vector. See, if you want to write it in short, you can also write auto, right? It will also work fine. But just I am doing explicit things. You can just replace this whole thing by auto. If you want to write less, yeah, you can do it in when you code it on your own. And what do you need? You need the dimensions, right? Vector vector int, and you have the next dimension m, and then you have another dimension k. Okay, and if you write nothing, if you would have, let's say, written -1, all of the elements would be initialized by -1. If you write nothing, all of the elements are by default going to initialize by 0. Okay, you do not need to take care of that. Okay, so I hope that is very simple, and the first cell of the DP I can easily fill up. Okay, so basically DP of 0 0, and what will be the first remainder? That is the first element in the cell, which is nothing but grid of 0 0. So what is grid of 0 0? Modulo k. Okay, and how many ways are there to reach the first cell from the first cell? There is just one way. Okay, so that's how you can just write this DP here, and you can then traverse through all the elements, all of the dimensions. Okay, then j would go from 0 to m, and what will you also get again is that you have the remainders. You also want to iterate through the remainders. So remainders can go from 0 to remainder can go till k minus 1, right, as I had already told you. And so earlier in the 2D version, what we were doing is that we had something like this cell, and we were adding the contribution from the top cell, and we were adding the contribution from the left cell. Okay, because they might have traveled down and right to reach this I comma j. But here also we will do the exact same thing. We will take the contribution from I minus 1 j and I j minus 1. These we will take, but we will also take account of all of the remainders. We will take that, we will see that hey, I minus 1 and j, you give me what are the number of paths when remainder is 0. Similarly, when remainder is 1, you give me again. Similarly, when remainder is 2, you give me again. So that is where I am introducing the third dimension. Hope you are able to understand what I am trying to say. Even from the left, I will do like this. From give me a remainder of 0 or 1 or 2, whatever be the case. I am just asking them to give me all the remainders also. Okay, because any remainder I do not want to leave out, because in future they might become 0, as I had already told you explanation. So yeah, what can you do? First of all, the first cell we have already filled out for I equal to 0 and j equal to 0, so we may want to skip that one. So if I is 0 and j is also 0, then definitely go on continuing. Okay, simply go on continuing. And what you will do for the remaining one is that if you try to see that if I want to take my contribution from I minus 1 and j minus 1, right? So if I minus 1 is greater than 0, greater than or equal to 0, I want to tell it like that. Then what I am trying to do, I will do dp I j and some remainder, let's say r dash. Okay, I will fill that dash, whatever that dash is. Let me keep a comma over here to remember, and I want to take the contribution from I minus 1, since I have just now checked I minus 1 is greater than 0, j, and the remainder. Okay, so if the remainder, you fixed any one of them, these both remainders are different, right? Because in the particular cell grid ij we want to add that one also. So in the previous remainder we are just adding the current value which is coming from grid ij, right? And we are taking a whole mod. That's what we are doing, isn't it? That's the same thing over here. That's what we were doing. So these two remainders are definitely different. So I choose to fix, let's say, this remainder. Okay, and then what will be the current remainder? So if the previous remainder, you see, coming from the previous cell, if the remainder was rem, what will be the new remainder? You see, if this was rem, the new remainder will be, you take this I comma j cell grid also. So remainder plus grid ij, and then you do a whole module. Okay, so that's what, I'm fixing this remainder, I'm adding this one to grid ij. Okay, and doing a whole module. Okay, I hope you are able to understand. Okay, if you are not, you are definitely free to ask me, and I add the contribution from this I minus 1j. Okay, so I hope you do get what I'm trying to do, and I will also check for j. Okay, the same thing I will do with j. If j minus 1 is greater than or equal to 0, then dpij I can write in the same way. Just instead of ij minus, I can write ij minus 1, and that is all. That is more or less. And what we want to return, we want to return dp and n minus 1, n minus 1, and 0. This is the thing which we need to return. So simply return dp n minus 1, n minus 1, and 0. Right. So we can simply look to return this. And I am missing out something. We are missing out this module, right? So just implement it quickly. I hope you do understand where we need to implement it inside this dp only. So dp is the thing which stores the answer, right? So there only we need to implement this 29 plus 7 modulo. So as we are adding this, instead of just plus equal to this, I can do a module. I can add this whole thing again, right? It will just look big, but it is not actually. And I will just add a modulo k. Okay, the same thing I can do over here. So you see, if I choose to do the same over here also, so yeah, that is fine. I guess it is just fine, and this should now, I guess, work fine. So this is not be modulo, here this will be modulo empty. Okay, so I guess that is all, and this should work just fine. Let's see, we all something will do that. Yeah, but we get a separate thing. If we try to submit it for all test cases, I hope this will work just fine. And that's all. The code was not so long. It was simple, and we get a decent runtime and memory complexity also. Yeah, how many lines? It's just less than 20 lines of code, right? So that's all. That's all for this video.